Welcome back to week 6, and in video 5 we are going to move forward into arid landforms. So what we're going to talk about first are what deserts are and the environmental conditions that produce deserts, and then we'll talk about some of the major types of deserts. And then the next video we'll get into erosion, deposition, landforms, and some hazards that are produced. So what are arid environments? Well, it's someplace that's dry. Deserts, dry environments, low annual rainfall, low weathering rates, sparse vegetation. Here's a picture from a desert in Texas. This is actually Big Bend National Park, right on the Texas-Mexico border. So very little vegetation. Wind is the dominant mode of sediment transport in these environments. So how do we create a desert? Well, we need to have dry air descending to the surface regularly, and the air that's descending is too cold to actually hold moisture, so it's not going to be able to pick up any moisture from nearby lakes or rivers. And then in some areas you have mountains that block moist air from the oceans. That's kind of the scenario for the Dalles in eastern Oregon. And in some places, some of that ocean air moves away from the land, so we don't get that wet air onto the land surface. And some of them are kind of a combo of these. And so to talk more about the types of deserts and the conditions at each, the major types, I've got 5 here: rain shadow, continental interior, polar deserts, coastal deserts, and equatorial deserts are the main types that we see. So talk first about the subtropical deserts. These are deserts that occur around 30 degrees latitude, right here along this yellow line in the middle. The equator would be down here. So what you're seeing on this image are surface trade winds by the red arrows on the map. We've got 0 degrees latitude, 30 degrees latitude, and then probably 60 degrees roughly latitude. And you have these cells that are air's kind of rotating, moving from the surface up to the upper atmosphere and then back down again. And these 3 cells are atmospheric circulation cells. And they're numbered. You can see the names of them down here. And basically, what we have is in the Hadley cell around the equator, you can see there's kind of mirror images of this. We've got lots of sun hitting the equator, the air heats up, we have lots of evaporation. So we have air heating up, air heats up, it's less dense, it rises, and as it rises and reaches the upper atmosphere, it starts to cool, and then eventually it will sink because it's too cold to stay up there, so it sinks back down to the surface. So it's that cool, dry, descending air, and as it hits the surface, it starts to evaporate as it travels across and heat up as it travels back to the equator. And then up in the polar areas, what we have is this is dominated by cool air sinking in the polar regions. So we've got cool air sinking right on the poles, traveling across the surface, maybe warming up slightly, and then rising up to the surface and back around. And so in the middle here, the Ferrel cell is kind of the gear stuck in between the others, basically. So it's kind of rotating due to the motion around it. And so those subtropical deserts are those ones that are occurring where that cool, dry air, you can see here, is sinking to the land surface, and then it warms up as it flows across the surface. And if we look at this map here, we can see those equatorial deserts or subtropical deserts occurring around that 30 degrees latitude. Like the Sahara Desert is a good example, the Sonoran Desert in the US. Rain shadow, so this is what's happening in our neck of the woods and in the Great Basin in Nevada. So a lot of deserts are produced this way. We've got prevailing wind bringing moist air off of the oceans. The air is forced up and over a mountain range, and as it's forced up, it's forced to cool. As the air cools, it can't hold that moisture anymore, so the moisture then condenses to form clouds and precipitation, and that Eventually, there's too much precipitation in that cloud. Gravity pulls it down, and we get rain occurring on the ocean side of a mountain range. And then as that air travels over, that air sinks, starts to warm as it's traveling over the surface, and it starts to evaporate any moisture that might exist on the opposite side, on the leeward slope. And so we get dry conditions. So this would be Portland. Hood River would be kind of here-ish, the Dalles, and then eastern Oregon. So oceanside deserts, these are deserts that occur right next to the ocean, so it kind of seems odd to have really dry conditions right next to a water source. But basically what's happening in these areas is you have the major air currents are pulling air from the continent up and over a mountain range and then out to the ocean. So this wind current brings the air across, drops any moisture on those mountains, and then to dry as it travels out towards the ocean. The Santa Ana wind is a good example of one of those that happens seasonally in California. So our next deserts are polar deserts. So this is where you have that cool, dry air sinking, and we don't have enough warm temperatures in that air to actually hold any moisture. So it's just too cold, can't hold moisture, so it can't fall or precipitate on the land surface. But any ice or snow that exists there is going to stick around for a long time because it's not going to be able to melt or evaporate. And then continental interior, so these are basically deserts that are isolated, they're away from any moisture source. So this is a good example here. You can see this brown area is a desert, and then it's pretty far away from any bodies of water. And those are the types of deserts that we have. So we'll come back, we'll talk about erosion, deposition, landforms, and hazards.